Yeah. Okay. So we saw in yesterday's session, we were looking at routing protocols, and some of the questions we had done. We've seen this question about drawing the network. We looked at interdomain services, the types of algorithms, this example of OSPF, and we said the next session would be discussion of molecular questions and the quiz. So what I plan to do is to discuss the questions for the quiz. So let's start. Let's start with that. So this is quiz 3. Okay. So question 1. Here is what the first blank was. So I'm not copying the options here. Let's try to answer this question. So if you're watching this, I hope that you've already taken the quiz and you're only seeing the discussion of the answers. So let's begin. The first question says, in distance vector routing, the first thing each node creates is its own something with the rudimentary information it has about its immediate neighbors. So yesterday we saw we have a node, we have all these nodes. The rudimentary information, what rudimentary information is this? You're getting things like the cost, the distance from each node. What is rudimentary? It's not giving you all the details about packets or anything. So what does it create? So the options were it could be a forwarding table or routing table, right? We saw that yesterday, or it could be the least cost tree. And the answer is actually in here. So when you see in a distance vector routing, since it is distance vector, that's why it has to be least cost tree and not routing table, because routing table does not do via distance vector. Instead, routing is it uses so when a packet comes, where should it go? It that information cannot come from rudimentary information from other nodes. Right. So the answer for this is least cost tree. Go to the next one. Question 2. Okay. Think it didn't copy. Let me try again. Okay. The second question was to create a least cost tree with the LS routing method, each node needs to have a complete map of the network, which is called the dash. Network topology, routing table, LSDB, routing algorithm, distance. So here I've put what the correct answer is. But let's say let's check why the other answers are wrong. It's because they've given us link state routing. We saw in yesterday's session, in the link state routing, I don't remember which question we had seen it, but we saw the main thing about link state routing, one of the main things, is that you have a link state packet and you have a link state database called LSDB. So that should be your answer. A routing table is not a map of the network, because a routing table is, what is it? You have the nodes. Each node has a routing table that tells it where each packet should go, where the packet should be forwarded, right? And that does not map out the entire network. A network topology table. What is topology? We saw star topology, ring topology. This is also not. This is a map of the network, yes, but it does not help to create a least cost. So that is also wrong. This is also wrong. Routing algorithm table. There is nothing there. That distance vector table. This is it's trying to get the least cost tree. It would be right if it was just least cost tree, but we're using LS routing, and the answer has to be link state database. So this is more of a memory question. If you know that LS routing calls LSTP by using LSPs, you'll be able to. Okay, let's move. Question. I pasted it wrong. Okay. So in RIP, the cost between a router and a packet is defined as the dash, which represents the number of subnets a packet needs to travel. RIP, we know routing information protocol. Let's go back to routing information protocol where we saw it yesterday. The main thing is that the distance in routing information protocol is hop count, where infinity means it's we don't have, so where there's no infinity in RIP, but instead it's 15. 15 means it is unreachable. So that's your answer, hop count. Is it a routing metric? This is too general. We need something specific. Network latency? Latency cannot be a cost because latency is something that keeps changing. It's not something that it's fixed. Hops is fixed because if you have a network, it will take only the same number of hops to get from one node to another throughout the lifetime. Link quality, no, routing information has cost. It's not using the holistic which we had seen yesterday. OSPF, it has a lot of things. Link state weight. If it was OSPF, link quality might come into play, but not in that. Bandwidth availability, no. Availability of bandwidth does not influence how the RIP works. Right? So here the answer is, so let me remove that bandwidth. Here the answer is hop count. Okay. So let's move on quickly next. Question 4. So here I'll try and remove the correct answer so isn't visible immediately. Okay. RIP uses 3 times. So let's go back to yesterday's thing. We saw RIP. We saw RIP has 3 timers: periodic timer, expiry timer, and garbage collection timer. We saw the uses. Periodic was just a periodic advertisement of the hop counts. Expiry is a time. It should update between, I mean, it should update within this time. If it is not, then garbage collection timer will delete the node after it expires. So let's come back to our question. RAP uses 3 timers to support its operation, including periodic timer, yes, expiration timer for root validity, yes, garbage collection timer to purge rules from the quality, yes. Periodic timer is randomly set between dash and 35 seconds. I do not know whether we saw yesterday. No, we did not. We did not put it yesterday, but you would have to know. So, how long is the periodic timer usually how long is the periodic timer normally set for? The answer here is actually 25. But what does this mean? You have random random between 25 and 30. This is equivalent to writing something like rand 25 to 35, which means you could get values like 26, 29, 24, but you can't get 24. 27, 23. So all these values are valid timers for the periodic time. And why is the periodic timer not fixed? So the reason is because we cannot set a defined timer such that, okay, so once this timer finishes, all nodes should be valid. It's the protocol is set in such a way that it allows a random time to be set in that 10 seconds width, in that 10 seconds range, and any random time is chosen for the periodic time. Um, so yeah. So is this a bad thing? This is another question. Significance. Significance. And let's write here. So let's say example. So what is the significance of this? Is this a bad thing if let's say this timer set at 25 and another network the timer set as 35? Which network would perform better? So you have which would perform better, the timer of 25 or 35? And the answer is actually they would be equal, because it does not matter how much the what is it, the one. So 25 timer. What is the benefits of having a 25 timer? It's going to have lots of checks. It's so the network is also going to be very reliable, because every 25 seconds it's going to check, where the second network only every 35 seconds, right? But the 35 timer has the benefits. It has less checks, so it's less work. So it's like less work on the network. So you're not checking so many times. Whereas 25 timer, you're checking so many times. You may be using a lot of resources. So it's actually a resource reliability trade-off. You want more reliability, you'll have to use the lesser time. If you want be more resourceful would be that. If you want to be more resourceful, you have to use something with a higher time. So not to cause so much difference between the chosen values, we have 10-second range that is different. Okay, that is all I want to discuss about RAP. Let's go to the next question. So, okay, question 5. Again, my answer key here shows the correct answer. So I'm going to just remove what is the correct answer and then paste it here. Okay, OSPF algorithm. So let's go back and see what is OSPF. OSPF we saw You have a link state to it. Right, we have LSAs, all these things. Okay, so the question is, what if routers can create forwarding tables using something, some algorithm, to find the shortest path tree from themselves through given Bellman Ford, A star search this class skills in Floyd Wash. So here you should straight away know that it's not A star because A star search is a heuristic searching. So we have not seen how. So a heuristic. So let me just. I know it's not part of this thing, but in heuristic search you'd have a distance and you'd have some heuristic. So, but in OSPF you only have some distance. You don't have some extra value. This is an algorithm that you might see in artificial intelligence. The other ones are possible to be Palanthos, registers, Kruskal's and Freud-Warshells also will not give you what you would need. So what we need is the shortest path tree from each node. And so actually the answer here is Dijistra's algorithm. Bellman-Ford equation is could have been used, but we need to know that OSPF uses Dijistra's algorithm. This is also another memory question. Right. Can OSPF choose another algorithm? Yeah, it can, but this is not defined by the protocol which has been set. It can though. And there may be some reasons for choosing Digistras over Crystals of Royal versions. Okay, let's move on. Question 6. I'm just removing the correct answer label before I paste it. So let's actually do this without the options. So we are given OSPF uses various types of something, including router link, network link, summary link to network, summary link to AS. AS is autonomous system, and external link, disseminate information about nodes, links, and costs within the autonomous system. So what they're basically asking is how does OSPF disseminate information? How does it do? So we saw before OSPF, it's link state routing. I'm sorry, it uses it keeps in mind reliability, bandwidth, latency, all these things. So how does it do it? What is the value that it uses to represent all this? Something called LSA. So let's go back to yesterday's notes. OSPF flooding, how does it take place? Through the link state advertisement. What is that link state advertisement? It's it's something that sends information. The question here was something that disseminates information. So the answer here is actually LSA. So don't worry about when they say so many different types of things. These are all different ways of giving an advertisement, different ways that OSPF can give an advertisement for the nodes. So LSA is used to go from all the nodes. Each node will send its link state advertisement. It will pass through all the nodes, and then all the other nodes can get to know what is the state of that link, what is the reliability, what is the bandwidth, all those things, right? So OSPF is we have previous OSPF question also. That was discussed. I think other questions are RIP. This one was link state discussed. Okay, so this is the answer. This is link state advertisement. Okay, so question 7. Let me remove what is the correct answer. Replace. LSTP can be represented as a 2D dash. In its value, each cell defines the cost of the corresponding grid, corresponding link. So here actually, what is a link state database? So I don't know whether we discussed last time. Oh, and here you can see link state types is given. Is router link, network link, summary link. That is the one that is there in the previous question. So LSTP is actually a database, right? But how is it formed? It's in the form of an adjacency matrix. So let me redraw this. So you have A, B, C, there also you have A, B. You would know what adjacency matrix is. And every cell in this matrix, this cell over here, what does it represent? It represents, let me highlight, this cell over here represents the state of the link between A and A, which is basically A with itself. So this does not matter. So let's take this one again. This cell over here represents the link between A and B. So if we had the network A and then you had B and then you had the link state of 4. So that 4 will be stored in this cell. Okay, so coming to a question, the SDB is represented as a grid, diagram, table, array, and matrix. So I've already said it's an adjacency matrix. So it's actually this one. All the other answers are similar table, spreadsheet, similar to matrix, table, diagram, grid, spreadsheet. But what they're looking here for is the correct term. You could say grid is not wrong, but in computational terms, it is a matrix, right? So if you had hit grid and you knew this, that's good. You have the good concept, but just need to worry about the terms. Okay, let's go to the next question. Question 8. This question we were asked, a multicast address is an identifier for dash, and it is used as the destination address for messages sent to that group. Network, server, multicast group, device, and broadcast. So I think in the quiz broadcast was not there, but okay. Network, server, multicast, or device. A multicast address. So giving this multicast is a bit too obvious. So the answer here is group, but let's see why it's not the other options. Let's say, let's assume it was A. So a multicast address is an identifier for a network. What does that mean? So if you have a node and you have many other nodes that are in a particular network, if an address was the identifier for the network, that means if it's sent using that address, it is sent to all the nodes in the network. And that is not that's not what multicast is. That's what broadcast is. Broadcast. Right? So it's not network. Is it the server address or is it the device address? Both of these mean you have a node and you're using multicast address. It's rated MA and it's being sent. And here you have another. Correct? And here you have the device, the server, or you have the device. So how many places are you going? What is the relationship between the sender and the receiver? We notice is actually a one-to-one. Is one-to-one a multicast? No, one multicast is actually a one-to-many. And one-to-one, what it actually is a unicast. You. So what server and device is doing is it's sending from one device to another device. And that is not what multicast is. Multicast sends to many, but not all. So for example, an actual multicast, if you had here and you had 1, 2, 3, multicast is set to to particular types of people, of the particular group of nodes. Just these two. This is also part of the network, but it does not send the message from the source. So that is why the answer here is group. Okay, let's move on. Question. So the next question is actually a very simple question. We've already discussed this answer when we were discussing the previous question. Let me paste it. In unicasting, the relationship between source and destination is dash with one source and one destination. So even if you say remove this part, the relationship between source and destination in unicasting, and we just now we saw in the previous question, what is it? One to one. So let's recall what all the types of casting. So rated casting. You have unicast, which is 1, 2, 1. Multicast, which is 1, 2, many. And broadcast, which is 1, 2, all. And so the answer here is actually 1 to 1. So there's not much explanation to do for this. It's actually a simple question. Should not, or what is often confused is the multicast and broadcast, because one is to many, one is to all. This many does not necessarily have to be all. It can be all, but not always. Okay. The last question in our quiz. Question 10. Let me bring up that question. It's a question that says if the LSP is dash, then another. The node keeps it while discarding the other. So what is LSP? So let's go back to our notes. LSP we had seen when we were talking about link state routing, LSR. LSP is a link state packet. And what does it say? Link state packet has the cost, the state of the link. So what is the cost? You have two nodes and you have a link between them. And let's say the cost assigned is A and B. A will send the LSP telling the rest of the network that hey, I have a link from here to B and that cost is equal to 3. That will be what is in this LSP message. It is flooded. But when will one LSP be discarded and the other will be accepted? So when will you discard the LSP? You could say that so the options were like if one is shorter, if one is smaller than the other. So let's say first you get an LSP, first we get an LSP saying A to B is cost 3. Then we're getting an LSP saying A to B is cost 2. This would seem like you would change and you would discard the old one and keep only this one. But would this ever happen? And the answer is no, because link state packets are telling the link state of one particular link. If they were saying the state of a tree, that would be something that constantly changes when you find a new shorter path, new paths, you're making the least cost tree. Then you would get something like this. But here you will not find link state packets that change the costs. But then what will you find? You will find new packets, new LSPs, and old LSPs. Right? And so the answer here is actually the answer here is actually newer. That is the answer that is there. That is the answer for this question. So if an LSP is newer, if a new LSP for the same thing comes, then the node will keep that LSP and he'll discard the other older one. Okay, so that's the answer for this question. So this was our quiz. Let's just quickly go through everything. We saw distance vector routing and how trees can be made. What type of tree it is? It's a least cost tree. Then we saw what is the database that is used in link state routing. It's a LSDB, the link state database, and we saw how it looks like. Uh, Agency metrics, Then we saw what is the cost in RIP considered to be? What's the cost that defines what an RIP is? That's hop count. Then we saw the how the timers are set and what are some examples and what is the significance. We had some. This is a good question for reasoning type of question. Um, then we saw the types of shortest path routing algorithms and how Dijkstra is the one that's used by OSPF and not the others. Then we saw how does OSPF disseminate information using a link state advertisement. Then we saw what is the type of LSDB, how is it represented? This is how it's represented as a two-dimensional matrix, two-dimensional array, which is the matrix. Then we saw multicast address, and this was a good question. It asked us what it actually identifies. Is it the network, or is it the server, or a device, or is it a group? And it was a group. We also saw on the side how unicast is different from multicast and broadcast. That helped us in our next question, where the question was, what is the relationship between source and destination in unicasting? This is one-to-one. And then lastly, we saw LSP, link state packet, and how if a new LSP comes, we'll discard the old one and we'll keep the new one, right? Okay, so that's all for this session. If you have not attempted the quiz, you can still attempt the quiz. That is, it's still open. The Google form is still open. You can use that and you can answer the quiz. And there's also feedback that is enabled, so you can check out what your score is, which particular topic it is that you are making mistake in, and maybe we can have a discussion about it in the next class. Else, we can start with another module in the next class. But yeah, that's all for the session. Thank you for everyone who has joined this session. We'll stop the recording now.